Uh, yeah, so let's start with something, whoops, about me. Um, my name, location, work. My name is Brauer. I live in Hamburg and I work as a freelance JavaScript developer. So we are not here to talk about me, but to talk about GrapQL. And yeah, let's begin. So, as a short overview, I will be giving a quick introduction into GraphQL for those of you unfamiliar. And then I will talk about the type system and how to query and mutate data, how introspection works and what that actually is. And then we will recap what we learned and why GraphQL is nice. So, before 2012, the mobile apps of Facebook were just web views and using their existing mobile websites. And at the end of 2011, beginning of 2012, Facebook decided to go truly native. So they experimented with a few different protocols to transfer data, some of them REST or custom endpoints per feature. And they experienced lots of problems with those. For example, with REST, they had to issue multiple queries just to get the data they need, which is really bad on mobile networks. And with custom endpoints, they had to develop a custom endpoint for each feature, which led to a huge maintenance burden. So they developed GraphQL. GraphQL lets you think about your data not as resources or queries like SQL, but it lets you define your data requirements in a natural format. And it is in use since 2012, and because GraphQL just defines the fields of the data you need, it still powers the first application Facebook released, which uses GraphQL. So, how does the query look like? As I said, you describe the fields you need, and it looks really like JSON without the values. And if you issue this query against the GraphQL server, it resolves the query to your data. It's very simple and easy to think about. And when Facebook first talked about GraphQL at the ReactConf in January, the community was excited, and some of them built their own implementations of the GraphQL protocol. And so Facebook decided to open source their GraphQL implementation and release a formal specification. They announced they released the formal specification in July at the ReactConf in Paris, and it's a specification for a query language, so it's language agnostic and storage engine agnostic. And besides the specification, they also released a reference implementation in JavaScript. So, the type system. GraphQL is based on a type system which is strongly typed to integrate with other languages, and it can be used to generate schemas for typed languages. The GraphQL schema is based on types, so you combine several types which from where on you can build queries against it. And the schema sets the entry points for the queries. So you have several entry points from where on you can explore the data. In the spec, they use a formal definition, which looks like this. It's very precise to define how a type looks like. And they also started work on a parser to use this format specification to write your types in JavaScript. But for now, we have to define our types in JavaScript. They look like this. So this is an object type. It has several fields, and it resolves those fields. So by default, a field uses an identity function. So the object, which is at the top level, uses the same keys for the fields if they are present. But you can also define a custom resolve function. And the resolve function can return data or a promise, which then gets passed to the data which is being returned. There are other functions. There are other types. Some complex types are interfaces and unions, which can be used to describe higher-level abstractions, and primitives types like bool, enum, int, float, and string. And yeah, when you query data, you write your data needs, and the server returns the data of the query. And because the resolve function gets past the parent object, you can nest this as deeply as you want, and still get some data. So, mutating. If you want to mutate your data, you can write a mutation query, which uses field arguments. So for that, the objects and the fields are like functions. So each function returns a value, and the fields can also accept parameters or arguments, as you see in this slide. And this query would mutate some data and return the user ID and name. Yeah, so introspection. GrapQL allows us to explore the schema itself. So with GrapQL, we can issue a query which returns us the schema and the type definitions of the schema we are using. And this allows us to do validation of queries and also to build some tools. For example, we can build IDE and editor integration, which does autocompletion, displays some descriptions to the fields, and displays errors or warnings if we are using deprecated fields. There are also API browsers and documentation generation, and tools like Relay, which we will be hearing of later. So yeah, I can show a quick demo of this. This is GrapQL. It's a tool built by Facebook to explore a schema, and it allows us to get autocompletion for the fields and actions we can do. So we can build a query. Let's use the brackets first. And we can see which fields are present in the schema. So, for example, we can query for all planets, and we can execute this query. And now we see all queries, all planets. Although we probably want to go a bit deeper and see the name, I guess. No? Planets? Okay, looks like this. Now we can see the name. We can also write an introspection query, which looks like this. We use schema, and then we can see all types and their names. So we see there's a root type, a string type, int type, films connection, and so on. And we can use this introspection to explore the entire schema and see what is possible and how we could structure our queries. Yeah, that's it. So GrapQL allows us to specify our data as we think about it. And it also prevents us from over and under fetching. So we don't get more data than we need, as we do in REST and with custom endpoints. And we can use it very well, very easily with hierarchical data like React components and their subcomponents. Yeah. So here are a few links. I will publish the slides later. And on GrapQL.org there's lots of information where all the demos and source code from Facebook and also community code is linked there. Then there's awesome GraphQL. It's a community maintained list on GitHub. And my small introduction server, which I showed at the beginning. Yeah. Any questions? Okay.
How do you manage versioning? So when your API changes?
You don't, because you don't fetch specific endpoints. You have just one endpoint, and you specify on the client which data you need. So when someone adds more types or different fields, it doesn't affect you because.
What happens when a field changes?
Good question. Then you might need to version it. You could, or you have to update all your clients. But I guess you can just put it on a different endpoint or try to not change your types.
Never changes.
Okay.
Maybe you should add. You could have different endpoints for different versions. So if you change your implementation, you point to another endpoint for the new version with a new structure. Maybe like that.
Yes.
Well, so I think a recommendation from the Facebook team was to never
Change your types.
never change the types, but just add new ones.
Mm-hmm.
And then you could add meta information on the old ones to emit warnings that they're deprecated.
Mm-hmm.
Yeah, right.
And deprecated is actually part of the schema, so it's not some basic just anonymous field, but it's in the protocol, so you can alert in your IDE if you're using deprecated fields, or you could just log errors if
there are 3 metadata fields for each type. You can use a description where you describe the type. And also there's a is deprecated and deprecation reason field, which can be used to show warnings or yeah.
Possible to filter the data, for example, just fetch data which is newer than a specific date or something like that?
If you specify field arguments for your queries, you can use them to implement filtering or sorting or whatever you like. Okay.
The update user slide
Yes.
you had, is that update user something that you kind of automatically get because there's a user defined, or is update user a defined function somewhere?
Update user is a field on some type, and it takes these field arguments to update the. So you would specify a resolve function, and the resolve function accepts 2 arguments, user ID and name, and then changes some data and returns these values. No magic, it's just the resolve functions. Okay. Yes?
Do you have an example which is showing the connection between the query and the real database?
In code, or so The example I showed earlier was is a very small HTTP server. Oh, sorry, yes. And for that, I wrote a schema which defines the types which I can use. So I have a link type, which is an object type, and it has the following fields: ID, title, and URL. And because on the object these look the same, they are named the same, so I don't need to specify a resolve function. I have a talk type here, which uses a resolve function to get the links for a specific talk. So in the resolve function, as an argument, I get the talk, which is currently being queried, and I can use the method find links to get the links of the talk. So this is not a database, but I have just some objects in memory, which is the speakers, talks, and some links. And I have a few methods here which can return me a speaker, talk, or return me links. So yeah, and those methods I use in the schema to resolve the fields.
How would you handle authentication permissions? Is there something built in for that, or you build it on top?
Good question. I Googled that myself a few days ago. There's nothing built in, but you could write some authentication into the resolve function. So in the resolve function, you get a context which you have on every level. So you could put in there the current user information, and then in the resolve function, before you return some data, you check if a user is permitted to access this data.
Would be just use JSON web tokens or stuff like that, and just pass them through, and even use that to authenticate against the backend where the data comes from. So the backend can still see if you have the capabilities to read the data that you described, but none of the systems in between have to care about it. They just validate if the token is valid and pass it on. So it's really simple because you just get the context and you can just pass it through.
How do you handle asynchronous functions and the resolve function? Can you return promises?
You can return promises, yes, and the resolve functions on each level. So all those fields can execute in parallel because they all get as get the current object as the first argument, and this allows to execute many requests in parallel. But except if you do mutations, then you need to do it sequentially. Yeah. Yes.
How do you handle queries with many related objects in... sorry, I can't explain English. Darf ich kurz Deutsch sprechen? Ja. Also es geht mir darum, wenn ich jetzt eine größere Anzahl Objekte anfordere, die ihrerseits wieder verbundene Objekte haben, die aus einer Datenbank kommen, dann müsste ich ja für jedes eine einzelne Abfrage machen. Einen Join kriege ich ja nicht hin im GrapQL.
No, with a resolve function, you in a resolve function you get the current object as argument, and then you can do the join inside the resolve function, for example. So you just specify, as you can see here, find links is a function which accepts an array of links of IDs and returns related objects to those IDs. So yeah, because you have the context of a current object, you can execute other functions which operate on this object or find related content.
what's the protocol like? Like the HTTP protocol, is it binary?
It doesn't matter. GrapQL is just a specification for the query language for those queries and types itself, so you can use any protocol you like. No.
Would you only use get, or would you also put post?
I would use post for mutating data, and post if the query is too complex, too big, but otherwise you can use get and it's just fine.
Do they have plans to make it more RESTful, or is it possible, or somehow? So for example, yeah, you could just use like, yeah, so this HTTP verbs was actually a good example, I guess.
I don't think so, no, it's just to post and get.
I mean, they don't limit you to anything. So, I mean, you can get the data via HTTP delete if you want, and still return. I mean,
that sounds great. I would do that.
It's just a problem, not in their problem scope. But one thing I wanted to add is like these links from data to data. You showed it before because you had these like depth of 3. But it's actually, this is so nice if you have like a person and you know how to get from a person to the friends of a person, where friends is actually a list of persons, where you can get the friends for each person in that list of persons again. Then you can actually build that very deep. Like you could limit like always get the first friend of a person and build a chain which is like 100 deep. And imagine this in a, I don't know, in SQL. Somehow you would basically recursively join your ass off. I don't know. You just don't have to change anything in the backend. Just write it in your client and you got it.
Yeah. Right. Can't find the slides right now. So, that's it.